So today we're going to look at some algebra review, looking at some basics that will help us going into our proof lesson tomorrow. All right. So slightly stepping into this. First thing we need to look at, adding two fractions, 3/4 plus 5/2. Okay, so obviously we need to simplify that. So then when I look at step 2, 3/4 plus 5/2 times 2/2. What's happened there? What have we done? We're doing a common denominator. So we're finding the LCD. All right, so now let's do and complete step 3. So we're multiplying together the second term. So we have the 3/4 plus 5/2 times 2/2 gives us what? 10/4. So right there we were simplifying the second term. And then in step 4 we need to write as one fraction. So what does that become? 13/4. So we add together the numerators, keep our least common denominator. So we get our answer of 13/4. Okay. So what have we done? We've just gone step by step. We haven't left out any steps. And then here we justified and told exactly what we were doing in every single step. So let's go down to number 2. We need to simplify 3/4 plus 2/10. Okay. What's first? Find the least common denominator. So we want to simplify. And we're going to simplify by finding the least common denominator. What is my least common denominator going to be? 20. So what do I need to do to my first fraction? All right, multiply top and bottom by 5. So I have 5/5 times 3/4 plus 2/10 times, what am I going to multiply my second fraction by? 2/2. Okay. So now we're going to simplify each term. So 5/5 times 3/4 gives us what? 15/20. Plus, what about 2/10 times 2/2? 4/20. And so now write as one fraction. So that is 19/20. So we've showed every single step. And then off to the side, we actually justified and told exactly what we did on each step. So now, is it going to be very much different when I move over to number 3? Is that really any different? Now we need to simplify 1/x plus 1 plus 2/x minus 1. Okay, so I need to simplify. So in order to simplify, what do I need to find? Least common denominator. What is my least common denominator going to be? Good. X plus 1 times x minus 1. So what's missing in the first fraction? What do I need to multiply the first fraction by? Good. So x minus 1 over x minus 1 times 1/x plus 1. Then I have plus 2/x minus 1. And what am I going to multiply the second fraction by? X plus 1 over x plus 1. So now we're going to simplify each term. So in my first term, I have x minus 1 times 1. So that's x minus 1 over the denominator, x minus 1 times x plus 1 becomes what? Multiply them together, and what do we get? X squared, what? Minus 1. plus, now I'm going to multiply 2 times x plus 1. What does that give me? 2x plus 2, distribute it, over x squared minus 1. So now, write as one fraction. So adding together my numerators, x minus 1 plus 2x plus 2 gives us 3x plus 1 over our common denominator of x squared minus 1. Did any of my steps change? No. Did I show every step? Yeah, and there we can see the justification was exactly the same. So now when we go to number 4, what looks different on number 4 as opposed to number 3? Oh, now we have sine of x. Okay, well, so instead of 1 over 1 minus x plus 1 over 1 plus x, in place of x, now we have sine x. But is the process of simplifying going to be any different than what we've just done on 1, 2, and 3? No different. So don't treat it any different. Just treat sine of x as our variable. That's it. So what am I going to multiply? And this time, I'm not going to write out the steps on the side, because are my steps going to change? No, steps aren't going to change. So first I'm going to simplify. So I need my least common denominator. What's my least common denominator going to be? 1 plus sine x times 1 minus sine of x. So my first fraction, what do I need to multiply my first fraction by? Good. So 1 plus sine x over 1 plus sine x times 1 over 1 minus sine x. Then I have plus 1 over 1 plus sine of x, my second fraction. What do I need to multiply it by? 1 minus sine x over 1 minus sine x. Okay, so now we're going to simplify each term. 1 plus sine of x times 1. 1 plus sine x over, what do you think we're going to end up with when I have 1 plus sine of x times 1 minus sine x? They don't cancel. What did we end up with when we had x plus 1 times x minus 1? X squared minus 1. So what should we end up with here? 1 times 1 gives me 1 minus sine times sine will give me sine squared x. 1 times 1 gives me the 1. The outer term, 1 times negative sine of x, and the inner term, positive sine of x times 1, those are going to cancel. And then sine of x times negative sine of x gives me minus sine squared x. So when we multiply sine of x times sine of x, we need to write it as sine squared of x. So make sure you put the squared right after the sine and not after the x. All right, then our second term, 1 times 1 minus sine x, gives us 1 minus sine x over 1 minus sine squared x. So I've now simplified each term. What's the final step? Write as a single fraction. So 1 plus sine x plus 1 minus sine x, what does that give me? 2. 1 plus 1, 2. And then sine of x minus sine of x, cancel. So I have 2 over 1 minus sine squared of x. So were those steps any different? Not at all. So right here, being able to do this, that's a big part of being able to solve a proof. As long as you can do the algebra steps behind it, you can do fine on this because it's just algebra steps. Okay? So now let's go, continuing with some algebra, factoring. On number 5, we want to factor 1 plus 2x plus x squared. Now I have it written that way for a reason, and I don't want to rewrite it. I just want to factor it as it is, as it's written. Do you have a question? Okay. So factoring it as is, what are the factors of 1? 1 and 1. So that comes first because that was the first term. What are my factors of x? X squared, I mean. X and x. Is there a combination of my pluses and minuses that will give me the plus 2x in the middle? Plus and plus. So 1 plus 2x plus x squared factors down to 1 plus x times 1 plus x. Okay. Now, let's look at number 6. This time, on number 6, I want to factor 4 minus x squared. What do we think that's going to be? 2 plus x, 2 minus x. So the 2's have to come first because the 4 came first. The factors of 4 are 2 and 2. And then minus, so that must mean I need a plus and a minus. And the factors of x squared are x and x. So I have to write it in the form 2 plus x times 2 minus x. So now when I look at number 7, factor 1 minus cosine squared theta. Is that really any different than doing 4 minus x squared? No, that's no different. The 1 factors down to what? 1 and 1. Because there's a minus there, I'm going to need a plus and a minus. And then what are my factors of cosine squared? Cosine and cosine. So cosine theta, cosine theta. So 1 minus cosine squared theta factors down to 1 plus cosine theta times 1 minus cosine theta. So it just looks a little bit different because now we factored with using a trig function. But again, if you just keep the trig function, either sine, cosine, or tangent, and treat it as a variable, the algebra is all the same. The algebra is the same. So now I want you on your own, factor number 8. All right, so as we factor number 8, how do we factor that? Okay, so there's an x in all 3, so I need to first factor out the greatest common factor. All right. So as we factor out the greatest common factor, I pull an x out, and then what am I left with? So pull out an x, and I'm left with x squared minus 2x plus 5. Now we look at what's left in the parentheses. Can we continue to factor x squared minus 2x plus 5? Does that factor? No. Think about what are the factors of 5? 1 and 5. Is there any combination of plus and minus with 1 or 5 that can give me the minus 2x in the middle? No. Nope. So that is completely simplified. So now I want you to try factoring tangent cubed x minus 6 times tangent squared x plus 5 times tangent x.
What is this strange magic?
No strange magic. Just treat the tangent as if it's a variable. What do we do first? Factor out tangent x. When I take tangent of x out of the first term, what am I left with? Good. So minus 6 tangent x plus 5. Now look inside the parentheses. Remember, just treat tangent as if it's a variable. Can that be factored? Yes, it can. So I bring down the tangent of x that was out front, and now we continue factoring. So tangent squared of x breaks down to what? Tangent x and tangent x. What about the 5? 5 and 1. What signs do I need? In both? Why do I need negatives in both? To multiply together to get the positive 5, and then add together to get the negative 6. All right, so that completely factors down to tangent of x times tangent of x minus 5 times tangent of x minus 1. Number 10, simplify x plus y squared. What do I do to simplify x plus y squared? What does that really mean that I'm doing? I'm multiplying x plus y times x plus y. Remember, it does not equal x squared plus y squared. You cannot just distribute the squared sign. It does not equal that. What we're really doing is we're multiplying out x plus y times itself. All right, so x plus y times x plus y. What's that going to give me? X squared plus 2xy plus y squared. Because we multiply together the first terms, x squared. Outer term is plus xy. Inner term is y times x, so that's another xy. Plus the last terms, y times y, is y squared. Combine the like terms, so xy plus xy gives me the 2xy. Okay. So now on number 11, do I do anything different when I simplify sine theta plus cosine theta squared? No. I don't do anything different. That just means I'm multiplying sine theta plus cosine theta times sine theta plus cosine theta. So sine times sine gives us sine squared theta. Outer terms is sine of theta times cosine theta. So sine theta times cosine theta, no different than x times y. Inner terms, cosine theta times sine theta is a sine theta times cosine theta. Plus the last terms, cosine times cosine is cosine squared theta. Do I have any like terms to combine? Yep. Sine theta cosine theta plus sine theta cosine theta. So I have sine squared theta plus what? 2 sine theta cosine theta plus cosine squared theta. So is that any different than the algebra we did on number 10? No different. So if you look on this page, if you look at number 4, 7, 9, and 11, the algebra we used on those was no different than normal algebra with either numbers or variables. The algebra is no different. So as long as you know how to do the algebra on 4, 7, 9, and 11, those are some of the main concepts that are used in solving proofs. Okay? So when we look at proofs tomorrow, don't be intimidated by it because it's just algebra. That's all it is it's the algebra. All right? So that is it.